Okay, in previous videos I've already covered solving quadratic equations with factoring and solving quadratic equations by completing the square, and those are great. There are a couple other ways you can solve quadratic equations, and one of them is to use the quadratic formula. The quadratic formula is nice because it will work 100% of the time. But in order to use it, you have to learn it. So that means you have to memorize it. And I have two methods for that. One is a song and one is a story. But before we do that, let me talk to you about the formula. This is the formula that we have to memorize. So it's x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And b, a, and c come from our equation, where a is the coefficient on x squared, b is the coefficient on x, and c is the constant. And in order for this to work, your equation must be set equal to 0. If it's not equal to 0, this no longer works. So that's going to always be your first step, is to make sure we're set equal to 0. So let's talk about how to memorize it. The first method is a song, and the song is sung to the tune of Pop Goes the Weasel, and I believe that most people would be familiar with that song. And you sing the exact formula to the tune of Pop Goes the Weasel. So it goes like this: x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. So I mean, it's exactly, you sing exactly what you're going to write down to the tune of Pop Goes the Weasel. So I'll sing it one more time. X equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and for some people this works really well. You sing it a bunch of times, it gets stuck in your head, and you know the equation. For other people, songs aren't necessarily the best way to memorize, and so I have a story. Here's the story, and each part of the story corresponds to a part of the formula. So what we have is a negative boy, and that corresponds to negative b. Ooh, wrong pen. Sorry about that. And he couldn't decide whether or not to go to the radical party, so he couldn't decide whether or not to go corresponds to the plus or minus. And then we have a radical party, and that corresponds to the square root, but he was square. So, sorry about that. He was square, so he's a boy, but he's square, so b squared. And so he missed out on, if we missed out on something, that's a subtraction. 4 awesome chicks. 4 awesome chicks, 4ac. Then we have it was all over. That corresponds to our fraction bar, all over, by 2 a.m., and that corresponds to 2a. So if you are writing the formula using the story, it goes like this. A negative boy couldn't decide whether or not to go to the radical party, but he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. And I'll go over that one more time. A negative boy couldn't decide whether or not to go to the radical party, but he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. So once you've used either of these methods or any method that you know of to memorize the formula, once you know the formula, then we can start to use the formula. So we're going to solve this equation using the formula, and the first step is always going to be to set it equal to 0. So if you look, we have x squared minus 12x equals negative 20. I need this to be equal to 0, so I'm going to add 20 to both sides. And that's going to give me x squared minus 12x plus 20 is equal to 0. Now it's in the correct format. Once I've set this equal to 0, my next step is to identify a, b, and c. Okay. A doesn't appear to be there, so that makes it a 1. It's an invisible 1. B is negative 12 and C is 20. Once I've identified A, B, I can then plug those values into the formula. Okay, and just because we're still practicing, I'm going to rewrite the formula. I have x equals negative b plus or minus the square root of b squared minus 4ac over 2a, and I'm going to plug those in. So b was negative 12. Well, it's a negative b, so it's going to be a negative negative 12 plus or minus negative 12 squared minus 4 times a times c all over 2 times a. Oops, I said a, I meant to write 1. Okay, so I have b, a, and c. The next step after I've plugged a, b, and c into the formula is I'm going to simplify under the radical. So I'm going to square and multiply. Okay. I'm also at the same time going to take care of this double negative. Now, if you've seen my videos before, I always make like a little smiley face. Double negative makes a happy face, so it's a positive. So I'm going to have a positive 12 plus or minus the square root. Okay, negative 12 squared is negative 12 times negative 12, so that's 144, minus 4 times 1 times 20, so minus 80, divided by 2 times 1, so 2. Okay, after I've done that, my next step is going to be to add or subtract under the radical. Okay, so I have x equals negative 12 plus or minus, okay, 144 minus 80 is 64 divided by 2. Once I've done that, I need to simplify the radical. Now in this case, I have a perfect square, so that's going to be relatively easy. I have x equals negative 12 plus or minus 8. Square root of 64 is 8 divided by 2, and I'm out of space. So I'm going to go to my next little blank here, and I'm going to rewrite that. 12 plus or minus 8 divided by 2. Okay, after I've simplified the radical, I need, oh wow, look what I did here. Be really careful about this. This is a good kind of learning experience. I brought my negative back, and I don't know why I did that. That doesn't belong there, right? Because he was happy, so now he's positive, and he remains positive all the way through. So just be really careful of your signs. It's a really common error to make. Okay, so once I've simplified the radical, I want to add and subtract the numerator, if possible. And I say if possible because if I have, for example, it wasn't a perfect square and it wasn't 64, let's say it was 128, then I would have 8 times the square root of 2, which I would not be able to add and subtract. And we will talk about what to do in those situations in a little bit here. But so we're going to add or subtract the numerator if possible. So in this case, I'm going to do 12 plus 8 and 12 minus 8. So I get 20 and I get 4. And once I've done that, I want to simplify. And that means I'm going to divide by the numerator or reduce if possible. And again, I'll show you what happens if you can't divide by the numerator. Okay, so in this instance, though, I can. So x is equal to 10 or 2. And I want to put that in set notation, and I get 10, comma, 2 in brackets. All right, so let's try a couple more examples. So what I'm going to do is I'm just going to write the quadratic equation here in the middle. I get negative b plus or minus the square root of b squared minus 4ac over 2a. My first step is I need to set my equation equal to 0. So I would be subtracting 18 from both sides. Or I can pick him up and move him, and he changes his sign. So that's what I did this time. I just picked him up and moved him. He was positive, so now he's negative. I'm set equal to 0. I'm identifying A, B, and C. And I'm going to plug them into my quadratic formula. I have a negative b plus or minus the square root of b squared minus 4 times a times c. Don't forget to bring your negative with you. All over 2 times a. I'm going to simplify. 9 squared is 81. 4 times 2 is 8 times 18. I'm going to cheat a little bit just to save time, and I get 144, so plus 144 all over 4. X is equal to negative 9 plus or minus the square root of 81 plus 144 is 225 divided by 4. Negative 9 plus or minus the square root of 225 is 15 divided by 4. So I have negative 9 plus 15. Oops, not 2, sorry. Divided by 4. Or negative 9 minus 15 divided by 4. So x is equal to negative 9 plus 15 is 6. And negative 9 minus 15 is negative 26. So that is going to reduce 3 halves and negative 13 halves. So those are my two answers. Right? If I come over here, I need to move both of these over to set it equal to 0. So 2x squared minus 12x, because it was positive here, so it's negative on this side, plus 18, it was negative, so now it's positive, equals 0. Negative b, well, b is negative 12, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I get 12 plus or minus the square root of 144. And I still have the same numbers, 4 times 2 times 18, but instead of being a positive 144, it's going to be negative because I only have one negative. Divided by 4. So I get 12 plus or minus the square root of 0 divided by 4. The square root of 0 is 0. So this is going to be 12 divided by 4, which is 3. When you get one answer like this, what you actually had was a perfect square trinomial. So if I divided all of these by 2, I would get x squared minus 6x plus 9. That's a perfect square trinomial. So that's why I only got one answer that time. Now sometimes things don't work out so nicely and you get non-integer answers. The steps are the same though. I have a, b, and c. We're already set equal to 0. So x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So I have negative 5 plus or minus the square root of 25 plus 144 divided by 6. Actually, this looks like it's going to work out just fine. Square root of 169 is 13. So I have negative 5 plus 13 divided by 6. and negative 5 minus 13 divided by 6. Negative 5 plus 13 is 8. Negative 5 minus 13 is negative 18. 8 and 6 both divide by 2, and that worked out. This one I need to set equal to 0. Then plug them in. Negative b plus or minus the square root of b squared minus 4 times a times c. Ran out of room there. All over 2 times a. So I get negative of a negative is a positive. So positive 5 plus or minus the square root of 25 plus 4 times 25 is 100 times 10, so that's 1,000 divided by 20. So 1025 divided by 20. And I'm not sure if 1025 is a perfect square or not, so I'm going to go ahead and factor it. Okay, so 1025 divided by 5 is 205. 205 divided by 5 is 45. 45 divided by 5 is 9, and 9 is 3 times 3. I have a pair of 5s. I have a pair of 3s. They can come out, and a 5 stays behind. So this is going to be 5 plus or minus 15 times the square root of 5 divided by 20. Now this is the situation where I told you a little bit earlier we're not going to be able to add those two because this has the square root of 5 attached to it, so I can't add it to 15. But if I look here, 5, 15, and 20 all divide by 5. So if I reduce and divide them all by 5, 5 divided by 5 is 1, 15 divided by 5 is 3, and 20 divided by 5 is 4. I cannot reduce under the radical. I can only reduce outside the radical. And so my answer is x is 1 plus or minus 3 times the square root of 5 divided by 4. And you can leave it just like this. Now, if you're asked to give your answer as a decimal, we'd take the square root of 5 into our calculator, round to the nearest tenth or hundredth, whatever you've been asked, add and subtract from 1, and divide by 4, and you'll get decimal answers. Personally, I prefer this kind of answer because it's more exact. Okay, so what I would like is for you to pause the video for a moment and go ahead and try these and see how you do. So pause now. Okay, here are the answers completely worked out. Why don't you take a moment and look them over. Go ahead and pause the video again so you can go through the steps and see how you did. Okay, so I mentioned at the beginning of this video that there are other ways to solve quadratic equations. In our last unit in my class, we did factoring and solving perfect squares. In the beginning of this unit, we've covered square roots, completing the square, and now the quadratic formula. And we're going to cover graphing in the next section. But you need to know when is the best time to use each method. Well, when it comes to graphing, use graphing when an approximate answer is okay. So the thing about graphing is we are not perfect, so we can't always draw a perfect graph. And also, the solutions to quadratic equations aren't always integers. So if you fall between the lines on a graph, how do you know what number it is? So graphing is good when you don't need an exact answer, when an approximate answer is okay. Factoring works best if you have a constant of 0. So that's the c. There's no number without an x on it, essentially. Or if you look at the at the expression, and the factors are easily identifiable. So factoring is not the best method if you have to go on a giant search trying to find the factors. And you also need to keep in mind that not every equation is factorable. So this is not always a method to use. Square roots, well, square roots can be used if you can write as x squared equals n. So you can be in this situation and take the square root of both sides. So you want no x term, just x squared and a number. Completing the square. It can be used for any equation. However, it's best if a is 1. So you don't have any number attached to the x squared. It's just by itself. And b is even because we have to divide b by 2 in order to complete the square. So that works best when b is an actual even number, and we'll divide by 2 so you get nice integers and you don't have to deal with fractions or decimals. Now the quadratic formula is sort of like the mothership of solving quadratic equations. It will work for any equation at any time. So it's a really nice tool to have in your math solving toolbox because you can use it anytime. Now it doesn't matter which method you use. If done correctly, they should all provide the same answer. Okay, no, graphing maybe not because we might have to approximate, but factoring, completing the square, and the quadratic formula, provided the equation is factorable, will all provide the same answer if done correctly. Now, figuring out how many answers you're going to have. We can use the discriminant for this. Thing is, when you have a quadratic formula, you have a squared, x squared. And that squared tells you your maximum number of solutions. So if I have an x to the third, my maximum number will be 3. If I have x to the fourth, my maximum number will be 4, etc. But that's your maximum number. That doesn't mean you're going to get 2 solutions. So you can use the discriminant in order to figure out how many solutions you have. So first of all, what is the discriminant? The discriminant is the part of the equation, formula, under the radical. So that's the b squared minus 4ac. That is the discriminant right there. And as I said, it's used to determine the number of real solutions. Now again, this is real solutions. So we're talking about numbers in the real number system. Okay. Here we have our equation. Our discriminant, again, is b squared minus 4ac. So I'm going to have 2 squared minus 4 times 1 times 5, which will give me 4 minus 20, which will give me negative 16. Now this negative 16, that's important. If the discriminant is negative, my graph is going to be up in space somewhere, and it'll never touch the x-axis. If it never touches the x-axis, I have no real solutions. Okay, negative. If I come and I try this particular equation, my discriminant is going to be b squared minus 4 times a times c So I have 100 minus 100, which is equal to 0. 0. Let me make that red so it stands out. Okay. If my discriminant is 0, my graph is going to touch the x-axis in exactly one spot. One spot right there. So I'm going to have exactly one real solution. Now it can touch anywhere along the x-axis, but it'll only touch in one spot. And then finally, my last example, I have negative 7 squared minus 4 times 2 times 2. So 49 minus 16, which is 33. And that is a positive number. And if I have a positive number, my graph, oops, wrong color. My graph is going to cross my x-axis in two places. And I am going to have two real solutions. So as you're working the equations out, you're figuring out the discriminant because you're under your radical anyway. As soon as you see one of these situations as negative, a 0, or a positive, you can figure out how many real solutions you're going to have. If you have a negative, that's it. You stop and write no real solutions. You can't continue. You have a negative under the square root. If you have a 0, you can continue, and if you have a positive number, you can continue, and you'll know how many answers you need to find, 1 or 2. So let's try some of those. We can figure out the discriminant on these, and then state the number of real solutions the equation will have. Now, I still have to have my equation set equal to 0 in order for this to work, because I need a, b, and c in their proper positions. So I have b squared minus 4 times a times c. Write that down up here again. So 25 minus 16 times 3 is 48, so I'm going to get a negative 23. Because I'm negative, I will have no real solutions. Okay, this one's already in the proper format, so I have 11 squared minus 4 times a times c. So I have 121 minus 120, so I get a 1. So I have a positive number, so I will have two real solutions. And finally, I have b squared minus 4 times a times c. Now, here's where I'm going to cheat a little. That's 900. 4 times 9 times 35 is 1260. I'm going to just double check that. 4 times 9 times 35. 1260. Okay, which is going to be a negative 360. And so in this one, I'll also have no real solutions. Okay, so that's what you can use the discriminant for. And that is the end of our lesson on the quadratic equation. I hope it helped.